In this video we're going to take the whirlwind tour of helpers. We've got the standard and position. Right now we're just going to look at standard. We've got the AND helper. AND can specify multiple inputs and input a bunch of booleans and check and see if they are all true. We've got add multiply. Add multiply, I take two scalars and add, subtract, multiply, divide, and create a new value. And it can actually output that value over the course of a second. It can do this on a per second basis. That's basically going to divide your calculations by whatever your frame rate is, so 30. We've got Boolean. Boolean's just going to output a true or false, and of course, like most TP operators, we can animate this. And we'll see him output those values. This is great for things like matter waves or fragmenting when you want to specifically control something. We've got a color helper. Color is going to allow us to take a color input and break it out into different components, or we can assemble different component values and output a new color, or do a translation between RGB and HSV. We've got counter. Counter is going to start at a value and count to a value, and it is going to output a true when his count end is done. When he's done counting, he's going to output a true, and you could trigger something else. While he's counting, he's going to be outputting the actual count integer. So frame 11, he'll probably be on count 11. And then we've got count normalize. This will be a 0 to 1 value over the course of his count. He has different methods. He can stop at the end once he reaches that. He can loop again. So once he hits 101, he's going to start back at 0 and start up again. Or he can ping pong, where he goes from 0 to 101, back down to 0, back up to 101, back down to 0. It's also got the option to count backwards, where he could count from 101 down to 0. And you can force reset this too, also by specifying this Boolean input, which will interrupt him and tell him to start over. Let's make a note though. Counter is very different than the initiator iterator. Iterator will output multiple and cause multiple operators to be updated multiple times per time sample. When I say time sample, we mean here on the master dynamic we got the viewport render subsampling, which we can do calculations per frame, per half frame, or specify samples per second. So iterator will output, in this case 59 times all in one time sample, whereas counter is only going to output one value. Even if he's counting to 59, he's only going to output his current count integer. So he's really good as a counter, which is why he's there. And then we've got expression. Expression, we're set, our master dynamic edit on the fly is turned off, so it's trying to evaluate this right away. It can't parse an empty expression. We'll just say OK. Expression's great. It allows us to input scalars and vectors. And then we can do things with those calculations. So any kind of scalar calculation, mix it with some vector calculations, and then output either a scalar or a vector. And then of course we can rename these, call that, oops, we want to actually add a vector input. If you ever need to compose a vector, just remember that the format is x, y, z, such as this. But if you're going to actually access an individual vector, in this case like the v vector, it would be v.x, v.y, and v.z. And then if we wanted to multiply this, each one of those by the a component, or a scalar, we could do that. Or pretty much any kind of combination of calculation you can want to do in there. Definitely check the Max help file's got a section called expression techniques, which is going to lay out all the available different types of calculations you can do and how to do them. I think the predefined variables, I don't think these are functioning, and all of the trig stuff works except for the special animation noise function. Okay, so that's expression. Then we've got float. Float can be used in multiple ways, like most things. It can either just output an actual value, or it can have a value come in. Maybe it's going to take a particle's age and we could take that age, and right now this float is set to added. So what's going to happen is whatever value is coming in on this value, this value is going to get added to it. Or we could multiply this incoming value by this amount. Even though this says value, it's important to know that if you expose the inputs, this would actually be the value 1 right here. So if you ever end up doing something like this, where you can have the float automatically calculate between these two, it's just going to ignore this last third value because you're overwriting this value 1 input with an input. Float can be used as also a percentage value if you need to do that, and it can be calculated over the course of a second, so it'll divide that up over time. Frame. A frame is very similar to float in that you can expose a frame to input as well as frames to add. This would be the frames to add field, or multiply, of course, and output a new frame. We've got get direction. Get direction we can use on a particle's alignment, and however he might be spinning or pointing or looking at things, we can get his direction and figure out what his x direction vector, y direction vector, or z direction vector is, and then use that in other ways. Integer, again, very similar to frame and float. We can expose this value 1, which is this guy, and whatever value is coming in will either be adding to him or multiplying him by what's here, and then outputting a new value. It was integer. Next up we've got intersect. Intersect is a nice new TP3 operator or helper it's actually really amazing. It can be used to kind of simulate raycasting. There's a sample file that you're going to want to check. It's called Iterator Multi. And Iterator Multi does an amazing thing where it can actually, let's go ahead and switch this around. It's a little long here, but what this is doing is it's saying, okay, born a bunch of particles. We've got a position input of 0, 10 up in Z. Going to born a bunch of new, a pistol shot of 100 with a bunch of emission distance variation. And then for each of those particles, iterate 20 times, generate, let's zoom in here, generate a random vector. We've got this box node here. Yeah, this is actually, it says it's a cylinder, it looks like a box. So this cylinder, what it's going to do is it's going to, per particle, create a new iteration, iterate 20 times, create 20 vectors, and using the intersect helper here to detect if any of those directions in that collide and intersect against that node. So intersecting can be done, say you had a particle flying through space, maybe flying alongside this box right here. And if you could set it up with an intersect so that he's calculating a bunch of different direction vectors, and those can have certain length. Speed as ray length is going to take this entire length in world units and detect if there's a collision anywhere within that entire ray. And then it'll output whether or not there's a hit. You can also output other information. Let's go ahead and expose that. Visible all. We can output whether or not it's hit, where that position is in world space, what the normal is, what the geometry's actual normal is, the distance to that hit, and whether or not it's a backside hit or not. So not the actual facing normal. And of course all these dynamic inputs you can use. So that's intersect. Let's go ahead and we'll reset and jump back into our tour.